All right, let's talk about the future. We've all seen the sci-fi dream, right? These sleek, lightweight smart glasses that you can wear all day, just seamlessly mixing your digital world with the real one. Well, that's the whole promise of spatial computing. But today, we're going to dive into the one huge problem that's been holding it all back and a really brilliant solution that might have just cracked the whole thing wide open. All the tech giants from Apple to Meta, they are all in a massive race to build this future. They see it as the next great leap in technology, something as big as the smartphone was. But the real trick, the challenge, is getting there with hardware that doesn't feel like you have a computer strapped to your face. I mean, the journey so far has been pretty incredible. We've gone from things like the HoloLens 2 all the way to the Apple Vision Pro. And these things are super powerful, but let's be real, they're still kind of big and bulky, and the battery life, not great. They're a long way from the comfy, all-day glasses we're all picturing. So what is it? What's the single biggest hurdle we have to get over to shrink all this powerful tech down into something that looks and feels just like a normal pair of glasses? Okay, let's get into it. The heart of the issue is this classic battle between power and portability. To make glasses light enough to wear all day, you have to get all the heavy-duty computer processing off your head. You got to move it somewhere else, like to a powerful computer nearby, or maybe even off in the cloud. And this solution has a name. It's called remote rendering. The idea itself is pretty simple. A big, powerful server does all the hard work of creating the 3D virtual stuff, and then it just streams the video of it back to your glasses in real time. This means the glasses themselves can be super simple, maybe with the processing power of just a smartwatch. But right here, this is the fundamental problem. On the one hand, if you do all the processing or rendering locally right on the device, it's instant, zero lag. But you need a heavy, power-hungry computer on your head. On the other hand, if you render remotely, you get those awesome lightweight glasses, but you introduce network delay or latency. And for mixed reality, that lag is an absolute deal breaker. This lag creates something that engineers call a position error. It's that awful, disorienting, even nauseating feeling you get when you turn your head, but the virtual objects in your room don't move with you instantly. They just kind of float or drag behind for a split second. It totally shatters the illusion and makes the whole experience pretty much unusable. But what if you could just hide the latency? What if you could make that lag totally invisible to the person wearing the glasses? Well, that's exactly what a team of researchers at National Central University in Taiwan did with a new system they call LARR. That stands for Localization-Assisted Remote Rendering. But how is that even possible? I mean, how can you get all the benefits of doing the work remotely without that crippling, experience-killing lag? Well, the answer turns out to be surprisingly clever. The big breakthrough idea is something they call an object streaming camera, or OSC. So instead of the server just sending one big video feed of the whole scene, it treats every single virtual object as its own separate thing. Each object gets its own dedicated virtual camera and its own personal video stream. So here's how it works step by step. First, the server streams the video for each object all by itself. Now, at the exact same time, your glasses know your precise head position in real time. Then, and this is where the magic happens, the system on your glasses uses that local positioning data to place each of those video streams perfectly into your view. The network lag is still there, technically, but because the final placement happens right on the glasses, you never see it. It's completely hidden. You can almost think of it like this. Every virtual object on the server has its own personal cameraman, and that cameraman's only job is to follow you, the user. This makes sure that no matter how fast you whip your head around, that object is always framed perfectly and positioned exactly where it should be in your view, completely masking any network delay. Now, this idea is absolutely brilliant, but you might have spotted a new problem. Streaming every single little object individually, well, that could use a massive amount of network bandwidth, making it pretty impractical. So the researchers had to add another layer of smarts to make it all work efficiently. So they built a system they call the Graph-Based Optimization for Streaming, or GOAST for short. And you can think of this as the brain of the whole operation. It intelligently analyzes the scene to decide what needs to be streamed, at what quality, and even how to group objects together to save precious bandwidth. And what's really cool is how this chart shows the trade-offs. Just look at the bars. So the traditional single stream on the far left, it uses low bandwidth, but you get that huge nauseating position error. Then the next method, just basic object streaming. It has low error, which is great, but look how high that bandwidth bar is. It's way too much. But then you get to the GOS framework on the right. It hits that perfect sweet spot.
You get the low position error, but it uses even less bandwidth than the old traditional method. Best of both worlds.
And the results are just staggering. In their tests with a scene that had 3 objects, this fully optimized LARR approach cut down the amount of data they had to stream by 81%. That's compared to the unoptimized method. I mean, it's not just a little bit better. That's a gigantic leap in efficiency. And this table, this is pretty much the final proof. Just look at the numbers for position error. The baseline method is really high. Other prediction methods are better, but you can see the error still gets worse as latency goes up. But now, look at that LARR row at the bottom. The error is an incredibly tiny 0.002, and it barely even changes when the latency doubles. It's just in a completely different league. It basically solves the problem.
And this isn't just theory either. The team actually built some real applications to prove that this works. They created these interactive optical experiments for students, an AI-powered ghost pet that you can actually have conversations with, and even this planetary exploration game called Star Whisper, where you can talk to AI-driven aliens. This is the kind of cool stuff that becomes possible once you get rid of the lag.
So let's pull back and look at the big picture for a second. This isn't just some clever technical trick. No. Solving this latency problem is absolutely fundamental to unlocking the entire future of computing and artificial intelligence. Because for AI to really take the next big step, it has to break out of our screens. As Forbes magazine put it, AI's next frontier is spatial. It needs to be able to understand, interact with, and exist in our physical world right alongside us. And this is the really crucial point. Lightweight smart glasses are the bridge that gets it there. They're the sensors that will gather all the real-world data needed to train smarter AI. They're the new kind of interface that lets us interact with tech using our gestures and our voice. And they're the display for AI agents that can actually guide us through tasks in the real world. You know, researchers have identified a few core things you need for any really high-quality mixed reality system. And you can see them here. But one of the most critical, right in the middle of it all, is a low-latency experience. If you don't solve for that, none of the other cool features, from having multiple users to remote rendering, can ever really deliver on their promise. It's the foundation that everything else has to be built on. And believe me, the race is on. As Mark Zuckerberg said earlier this year, everyone is scrambling to figure out the right path forward for AI glasses. The company that figures out how to deliver the seamless, lag-free experience in a lightweight device, well, they're going to define the next era of computing. Just think about it. The smartphone completely reshaped our world for the last decade and a half. With breakthroughs like this LARR system, the question isn't really if a spatial computing future is coming, but when. Are we finally seeing all the pieces fall into place for the device that will define the next 15 years?